Hello guys, my name is Diego Pacheco and this is a slidecast. And today I'm gonna talk about testing and how we can deal with team dependencies in tests. So let's get started. Every backend engineer kind of is aware about the testing pyramid, right? So the testing pyramid says that going down, it means that you are going faster, right? And going down to the pyramid, it means going more like unit tests rather than services or integration or sub-integration tests, and definitely faster than UI or end-to-end or full-fledged UI system testing. However, there's two kinds of unit tests, right? There are unit tests, the test classes that are isolated by nature and kind of a local and not using any external systems. However, there are other classes that they have dependencies on external systems, and that's where going faster only happens because we are somehow dealing with these dependencies. But not always dealing with these dependencies will mean that we're gonna go faster, right? So today I want to talk a bit more about that and also talk about some techniques and some important considerations on this landscape and how we can deal with dependencies in tests, right? So first thing we need to understand it is test doubles, right? So currently there is this game called Among Us, which is pretty popular, and in the game there is this notion of the imposter, right? Which is someone who's trying to sabotage the ship and is working against your team. But here is the other way around, right? So test doubles are like good imposters. And one thing that people doesn't know, right, that are multiple flavors of test doubles. Like there are fakes, there are mocks, there are spies, there are stubs, and dummy. Okay, and the motivation for that it is you want to verify your system or your piece of software, right, when the dependency is unusable, right, and either because it is flaky or it is full of instability, or it's a legacy system and it could be either a desktop or mainframe application, so it's really expensive to call it, or that will take a long time, and you want to avoid these low tests because we want short feedback cycles, right? So we want to get feedback as soon and as frequent as possible, as Agile says. Wrongly, people call all forms of test doubles as mocks, and everything is a mock, and that's really not the case, right? So here on this diagram, we have the sort of concepts and concerns that happens in tests, right? So you have the SUT, system under test, right? And then you have the target that you are testing, and you have like a test double there helping you to deal with the dependencies, right? And then in your test, you kind of have these patterns, this life cycle where first you do some sort of a setup, setting up test doubles or your strategy to deal with dependencies. You do some exercise, meaning the actual calling APIs. Then you do some verifications, often through assertions. And then you tear down any sort of state, or you make sure the tests have a clean shutdown, right? So in this presentation, we're gonna cover more details, the other forms of the test doubles. I like the word double, right? Because if you think about movies, you have stunt doubles, all right, in action movies, right? And then they are kind of not the real actor doing that thing, right? But funny enough, in movies, the double actually does the hard part, right? Does much more than the real system. And here's the other way around, right? It's like this is like action doubles, stunt doubles in reverse, right? So with that, we have a sort of ontology where test doubles are kind of everything, like the modern interface or the modern abstract class, not mocks like most of people think. And then you have these other specializations or flavors like dummies, stubs, spies, and mocks are very close cousins, and fake objects. And we're gonna talk about all them. But before, we need to understand that this is sort of a paradox, right? But we are working with doubles, test doubles, because we want to reduce the complexity and the expensiveness of a test. So we want to make the test more reliable and cheaper somehow, right? But not all doubles are created equal. And basically, there is a cost, there is a complexity involved on each double, and you cannot use the same kind of a double for all scenarios, right? Mocks are very complex, and they are the most popular way to do things, and they popularize because you can pretty much use mocks for everything, but even you are calling it a mock, some things are not actually mocks, right? And we're gonna see that. But I just want to comment two things here on this picture, right? One is, as you can see, dummies are the most easier way to make this stunt doubles, right? Or this fake or this imposters that we're talking about. And fakes here is classified as the most complex one. I kind of disagree with that, right? For me, I feel like mocks are much more complex than fakes because it really depends off the fake, right? But often I see that fakes can be much easier than mocks, right? But anyway. So let's start with fakes. So fakes, they are objects with working implementation, right? Although the name means fake, they are real, right? But they're not real as the production ones. They don't do exactly the same thing as the real production implementation, all right? So they have this property and this characteristic of being dynamic. So you can add data, right? So what happens is like they use shortcuts and they're sort of a simplified versions, right? So imagine like you have a user service and you have a DAO repository using Postgres, right? Or using Redis. So that's your real implementation. But then with a fake, you could have a fake with Redis or fake with Postgres, which you could ultimately implement as a hash map, right? So dynamically, you would be able to add, remove users like you would do in Postgres and in Redis, right? But the difference is that's in memory and that's in your probably local JVM. So this is not becoming a remote dependency. This is became a local dependency, right? So the speed is much faster and it's fairly more simple and reliable. And because it's in memory, it's faster to execute. But long story short, fakes are they implement your operations, right? So they are dynamic, but they are generic. That's one important thing to keep in mind. Now the next flavor is stubs. So stub is a simple mock or a simplest form of mock possible, right? So they hold predefined data, all right, and they use that data to answer questions on the tests, right? And although that might sound philosophical, it's just methods with hard code values, right? So when when we cannot use real data because there's side effects, like I said, is a legacy system. Often we, when the target code does not allow you to control input objects, or you don't have an easy way to set the target system in the state that you want, right? So you can simulate that state easily with stubs, and they're very, very easy to do. You don't need any special framework to do stubs, neither to do fakes. So stubs are similar to fake, but they're static, right? They're not dynamic. They don't have like a memory hash map like often you usually do with a fake. Like in one way to think about this, imagine like you have a bank or a financial, you are in financial industry, or you are in a well-regulated industry where you have like a credit or let's say user data, PII data, and or you are, let's say, Google Cloud, right? And you cannot have PII data outside of prod. And then what you want to do is, okay, so how I test this without having to deal with encryption and decryption, right? Well, you could have a stub that has turned the data for you, right? And then in that case, you can easily replace the whole encryption system. Another example, it could be like you need to do some sort of a background check, and that take days, right? So let's say we have a profile service in order to enter this organization. It will be background checks, like police checks or whatever. Then imagine that data will be either stored like on Redis or Postgres or any other data store, really, right? But let's say Redis. What you can do is to create a stub, right? It doesn't access your real customer's data and then return a specific John Doe user, right, all the time. So stubs, they're not dynamically, they are fixed, right? So they're much easier to do. Now we go to mocks, which I believe everybody is familiar with. They are much more complex than fakes and stubs. They register calls when they are invoked, and you can verify if some actions happened, right? And you can also tell then what happens when some method is called with a specific parameter. So you fully control the behavior under the hood, right? But the issue is often you need to do class by class, right? And you have a lot of classes. The effort to mock can be high, very high. So they are much more complex than stubs. Common solutions on the Java land are Mockito, Easy Mocks, Power Mocks. And one example is, let's say, you have a method that return void and send emails under the hood, right? And you want to verify if that email was called, right? So that's mocks, right? There is a specialized form of mocks, right, which are spy. And the reason why I explain this is exactly because my answer in mocks, right? So in mocks, we can mock the email, so I don't want to call the email, right? So then it doesn't blow because I don't have the email SMTP settings there. But I don't know exactly if that was called or not, and that's what the issue that spies can fix, right? The issue with spies, it is often it means we have some sort of at minimum suspicious design, let's say this way, right? And that design easily can be wrong, right? So the best thing to do, it might be to change the design so it's easier to test, right? That could be the case. That might not apply to all the cases, right? And one reason maybe is because you have a legacy system or is a third-party proprietary system, or the other reason I will explain later on the slidecast. But there are special kinds of mocks, all right? You also can register some information how they were called, and you can capture if they was called or not. So they capture the target method, and they know if they're called or not, and they can know how many times they're called, right? So in my previous incomplete example with mocks for the email service, we could know if that email method was called and how many times was called. Let's say we're expecting to be called 5 times. We don't care exactly what happens on the method. We just care that it was called 5 times, for instance. So we can do some sort of verification like that with spies. Finally, we have dummies, and dummies are cool as well because we don't need any special framework or language to do dummies, right? And mocks are complicated because often we need a special framework to do it, all right? And some things are extremely hard to mock, but it's possible. So like fakes and stubs, dummies can be done with any language. And dummies especially, they don't have an implementation. So they're much simple to do it. It's basically you just implementing interface at maximum, right? And you can either have different kinds of dummies, like it could be a value or attribute dummy, or it could be an object dummy, right? An object dummy is just you implementing any interface, for instance, that your dependency might need, right? So dummies are often used to satisfy a method argument need. They could be either, like I said, dummy values or dummy objects. And you need pass a parameter that you don't care or is not useful for your test, or is like a notification callback or customization, parameterization you don't need, and then you can use a dummy. So it's a good way to speed up some of your tests, and because they don't have dependencies, they're likely to be breaking much less than your mocks. Now, I mentioned before that besides legacy systems, there might be things that it might work in different rules, right? So one thing is when we're talking about SOA or microservices, right? They have some sort of expected behavior and way to work with them. And I would argue that services and microservices, you actually you want to use a form of a DI and IOC, dependency injection and version of control, because not only it will make sure your design is easier to test, but it's easier to configure and change. However, not all pieces of software are the same. So there is this common thought that I want to give sort of an unpopular opinion here, which is, people believe a good design should be always easy to test, right? And if you're not easy to test, you're doing the wrong thing. Well, for a service, I think it's true, and in several cases I understand why this is true. However, if we think about shared libraries, I think this might be an exception, all right? And the reason for so it is you really want to hide implementation details, right? You want to reduce your public control surface, right? Either by having less public classes, less public methods, and less things your users can hack and can extend, because everything they touch you will need to maintain, right? So library design is different than service design, folks. So we want to avoid coupling with DI and IOC, and the reason if we think about, like in Java, for instance, like Spring is not lightweight anymore since a long time, and we don't want to have that dependencies on our shared libraries, because that could easily be the recipe to build a distributed monolith. We also want to avoid coupling, all right, because like I said, we want to reduce the surface for customization, for parameterization, and therefore, by doing so, we would be leveraging abstraction. We would have better abstractions, and with better abstractions, the result is you have something which is much easier to maintain, is much more reliable, and as time passes, you need to do less migrations, right? And that's really key for speed at scale, right? However, as a result of that way of thinking, your tests will be a bit harder to do. They will not be impossible at all, right? They just feel a bit weird. And that's fine, actually, right? And not necessarily wrong. Finally, I want to talk about cross-cutting concerns, like ALF, for instance. ALF is an example, right? So if we think about architecture or requirements, we can have functional and non-functional requirements, right? And they can either be cutting or cross-cutting. So cutting, imagine something more like vertical, right? And cross-cutting, imagine something which is horizontal, right? So auth is often implemented in centralized fashion, right? So you often have a service for authentication and authorization. That service could either be created on in-house or could be using some popular SSO solution. But and often what people do, they have a proxy and based it on the URL or based it on a missing token, they redirect to that service, the login happens, then you get the token, and then the other services, as long as the token is there, they don't need to do anything, right? So it's completely transparent and easy to test in isolation and easy to disable in service, right? You just provide a special header or a special token there, and then you can easily move on, right? But imagine that this cross-cutting concern was implemented in a vertical manner, right? Meaning like a cutting concern, not a cross-cutting concern. Well, for that case, what would happen, right? It is that for tests it will be much harder because you cannot easily switch this off like a feature toggle. You cannot easily mock it in a generic way. You kind of need to do it in a different way, services by service, right? If every service deal off in a different way, right? So you really increasing the cognitive load, and you are really making hard to test, right? And the reason is because you made something which was cross-cutting. It should be horizontal, but you implemented vertically, right? You implemented tactically service by service, right? And that's what you need to be careful, right? That's if something is cross-cutting and you don't implement it in a cross-cutting way, testing could be really much harder. And the bottom line is you need to watch is, sometimes if you're mocking too much, it could be that you have a design problem, or it could be like, you have too many third-party dependencies and then the complexity was pushed upwards, or it could be that, it's better for that case to do more like integration tests, or it could be the case that you have a cross-cutting concern that was not implemented in a cross-cutting way, right? And that is what's generating the complexity that you need to deal with it. So always watch for too much mocks. That now there's several other ways to deal with the problem, like with fakes, with dummies, with stubs and spies. So that's it for today. I hope you guys like it. See you next time.